Okay, so the first example we're gonna have what is this guy. Calculate the inverse transform of the this guy. Okay, calculate the inverse of this guy. Okay, I'm gonna give you guys 1 or 2 minutes. Try it by yourself. Try it by yourself. Okay. Okay, so let me write down something on the board. So the first one is s plus 1. We're gonna use a divided by s, b divided s plus 1. Okay, so we times this guy for both sides. Okay. So we're gonna have what? We have a times s plus 1, b times s, right? And then you can combine all the terms, a plus b, s plus a. Okay. And we're gonna have what? A plus b equals 0. A equals 1, because on the left-hand side, we don't have s. So the coefficient of this guy gonna be a plus, the coefficient of s should be 0, right? That a plus b equals 0. And after you solve this guy, you're gonna get what? You can easily get a equals 1, b equals -1. Okay, and then we can tell the original inverse can be written down by what? By this guy, 1 over s minus 1 over s plus 1. Okay, and then you can write down as like that. Okay, like that. And then we can follow the formula. 1 over s, the inverse of this guy will be what? Will be 1, right? 1. And the 1 over s plus 1 gonna be e to the power -t, because the a is -1, right? A is -1. So e to the power at gonna be e to the power negative t. That's it. That's it. Okay. And then today I'm gonna give you a new, more complicated one. Let's take a look another one. Okay, another one. Let me check. Let's take a look at the wait a second, I forget which problems is. Oh, let's take a look at this guy. So, for example, how to find the inverse of 3s s squared plus 1 s plus 1. Right? So how to do that? The same things like the previous example I mentioned in the last class. So we have this guy, we can write down like that. Okay, do the fraction decomposition. Fraction decomposition. Okay, now try it. I want you guys get what is A, B, D. Okay, these three coefficients. Okay, try it by yourself. For three, I give you guys 2 or 3 minutes. Okay. Okay, let me write down the answer on board. So let's take a look. We times these terms together for both sides, right? We cancel out this denominator. We have what? We have right? We cancel out this term, and we're gonna have this term for the first term on the right. We cancel out this term, we're gonna have s plus 1, okay? Then we're gonna do the distribution. We're gonna have what? We're gonna have three s squared plus a distribution. Here again, gonna be s squared plus b plus d, s plus d. Okay, and so we can combine the terms. A plus b, s squared, b plus d, s, a plus d. Okay. Now you're gonna have what? You have these three coefficients, right? Equals left hand side. Since right hand side we don't have s squared, we're gonna have what? Equals 0. B plus d equals 3. A plus d equals what? 0. Okay, 0. And then we're gonna solve it. Basically, I think it's not too hard. You can find these three parameters from these three equations. D equals 3/2. Okay. You got these three parameters, then you can plug in back. You got plugging back, and right, you got this one. And now, since here for the numerator we have s and the constant, we can spread these two more, right? We can spread these two more. We can spread these two more, and then we're gonna have what? We're gonna have these three terms. Okay, and of course we can check our formula. From the formula, we now got 1 over s plus 1. So we can just put our constant outside. Put this constant outside because the formula tells us we only keep the s in the numerator. We can put 3/2 outside. And for this term, from the formula we can see we can just keep the this term, right? This term. We can put 3/2 constant out of the inverse transform. Okay. And for the first term, follow the formula. That is e to the power negative t. For the second term, that is 3 over 2 cosine. This is a cosine t. Cosine t. Okay. And for the third term is 3 over 2. That is sine t. Okay. Sine t. That's it. That's it. Okay. So basically, these are the last two examples I want to address today. I would like to take a look whether I have another examples. Oh, I have the last example. Sorry, I have the last example. The example is like that. Example 3. So Laplace transform of 8 s3 4 s squared plus 15s plus 26 s to the power 4 13s squared plus 36. Okay, and what are we gonna do is what is domain decomposition. Yeah. Oh, sorry, I can put this one as this one will be much easier. Okay, I change it a little bit. Will make this problem a little bit easy, otherwise too complicated. In the denominator is s squared plus 4 times s squared plus 9. Okay, so when we do the domain decomposition, we're gonna have what? We're gonna have as plus b s squared plus 9 cs plus d s squared plus 4. Okay, we can do it like that because in the denominator we have s squared. Okay, so in the numerator we're gonna 1 degree less. Okay, here's a square, we have 1 degree less, gonna be as plus b. Here's the s squared plus 4 cs. Now try it by yourself. I gave you guys 1 or 2 minutes. Try it by yourself. Okay. Okay, now let me write down the answer on board. So 8 S3 4s squared 157s 26. We times this guy for both sides, right? We cancel out. And then we're gonna have what? We're gonna have distribution, right? Distribution. We for the first term, distribution as cubed plus bs squared 4as plus 4b cs cubed plus ds plus 9 cs plus 9d. We're gonna have what? A plus c s cubed b plus d s squared for a plus 9c s for b plus 9d. Okay. And now we're gonna have what? A plus c equals 8. B plus D equals 4. 8, 4. For A plus 9C equals 57. For B plus 9D equals 26. So we're gonna get A equals 3, B equals 2, C equals 5, D equals what? D equals 2. Okay, so that's the answer. You can solve it because we have 4 unknowns, 4 equations. We're supposed to be able to solve it. Okay. Now, after you got this one, then everything should be very straightforward. Let me write down the answer for you guys. We're plugging back. We're gonna get this one. 3s plus 2 s squared plus 9 5s plus 2. Okay. And the things here in the numerator, we have S10 and a constant. S10 and a constant, we can spread this S10 to two terms, right? Okay. And again, we can solve it. Oh, sorry. Basically, we can solve it. We solve this 4, right? We spread to 2 terms. If there's a constant, you can put a constant outside. Okay, constant outside. And for the first term, we can know the k squared. K is 3, right? So we use cosine 3t. And the second term, of course, 9 is 3 squared, right? So it's sine 3t. For the fourth term, we see that is 2 square. It's cosine 2t. Here's a 2 square, right? So we have 2 sine 2t. Okay, sine 2t. Okay,